Hello, I'm Papia. Today we have a function f of x is equal to x plus 2 divided by x squared minus 3x minus 10. We have to analyze discontinuities of this function. So first we have to figure out if there are any x values where the function is not continuous. And then if we do find some points of discontinuity, we have to figure out if they're removable or not. So let's start with the expression of the function. Notice that this is a rational function. It has a denominator, which means there is a chance that the denominator might become 0 at some x values. If it does, those are the points of discontinuity. So we can start by factoring the denominator. So let's do that. Keep the numerator as it is, and then denominator is just a quadratic expression, so you can factor. Let's see, we have negative 10 here, so 5 times 2, and this is negative 3, so it'll be x minus 5 times x plus 2. Okay, that is x squared minus 3x minus 10. Now, each factor in the denominator, when it is equal to 0, you have a 0 in the denominator. So each factor will give you a discontinuity. So what are the x values where the function is not continuous? First value is when x minus 5 is equal to 0, which means x is equal to 5. And another value is when x plus 2 is equal to 0, which means x is equal to negative 2. So there are two x values where the function will have discontinuity. So that completes the first part. Next, we have to figure out which one of these two are removable. So what is removable discontinuity? It is such a discontinuity so that if you are able to redefine this function in such a way that you can remove the discontinuity, then that one is called removable. Now, in order to understand it, we have to understand what is happening to the function close to these 2 points. Okay, so let's start with the first one. Let's analyze the point x equals 5. Okay, let's see how the function is behaving around x equals 5. To understand that, all we have to do really is evaluate a limit. So evaluate limit as x is approaching 5 of the function f of x. That will give us an idea where the function is approaching to as x is approaching to 5. And looking at that, we will be able to figure out whether it's removable or not. So let's try to compute this limit. Function is x plus 2 divided by, I'm going to use this expression since I already have the denominator factor, x minus 5 times x plus 2. Now notice, you're probably wondering why I'm not cancelling these two terms. Well, I will now, because I'm computing the limit as x is approaching to 5, which means there is no point where x will be equal to negative 2, and therefore we can cancel this, because x is not negative 2. So if you cancel it, you will end up having 1 over x minus 5, and x is approaching to 5. So think about it. X is getting close to 5, which means the denominator x minus 5 is getting close to 0, which means 1 over a small number, that means the whole thing is blowing up. So this expression is approaching to some kind of infinity as x is approaching to 5. Precisely what is happening, you should be looking at the two one-sided limits. So if x is approaching to 5, say from right side, which means x is bigger than 5, this is a positive quantity, so then the limit will be positive infinity. And when x is approaching to 5 from left side, the left hand limit, see, this will be a negative quantity, minus 5. This whole thing is negative. This is approaching to a negative infinity. So if you want to look at the graph, kind of a rough idea, so we are looking at x equals 5, right? So you realize that this is a vertical asymptote at x equals 5. So we'll have an asymptote here. And the function is approaching from right-hand side, it's approaching to positive infinity. From left-hand side, it's going to negative infinity. Something like that, a rough graph of the function. Okay, now let's think about that discontinuity. Is it removable? Well, can you redefine the function? Can you say at x equals 5, function value is something so that the whole thing will be continuous? No, right? We can't, because look at these two different branches. You cannot bring them together in any way possible, which means this particular discontinuity is not removable. Okay, let's do the same thing for the next one. So next we have the point x equals negative 2. Well, we do the same thing. We compute a limit. And its limit as x approaches to negative 2 of the function. So this is limit. X is approaching to negative 2 of this expression again. X plus 2 divided by x minus 5 times x plus 2. Okay, big question. Can we cancel x plus 2? Yes, we can cancel it again. Guess why? Because x is approaching to negative 2, right? X is never going to reach negative 2. So this is again okay, because x is never equal to the value negative 2. It's a limit. So we can cancel. As soon as you cancel, you end up having 1 over x minus 5 again. But this time x is approaching to negative 2. So you can do a direct substitution to evaluate the limit. So if you plug in x equals negative 2, you get negative 7. So negative 1/7 is your answer. All right. Let's understand what this means. The limit exists, but the function is not defined at that point, at negative 2. So if you want to again look at the graph of this function, so say here is your negative 2, okay? As x is approaching to negative 2 from both sides, the function is approaching to a value negative 1/7, say somewhere here, right? Okay, the function is not defined, so you will have an open circle, right? But the limit exists, so the function is approaching to that point somehow. The limit exists, but function is not defined. It's an open circle. Now think about it. Can we redefine this function to remove that discontinuity, to make that open circle a closed circle? Yes, we can. How can we do that? So we can redefine the function f this way. We say we keep this function exactly similar, x plus 2 divided by x minus 5 times x plus 2 everywhere except at negative 2. Now what happens at negative 2? We make the function value equal to the limit, negative 1/7, as x is equal to negative 2. So if you define it this way, guess what happens? This new function will have no discontinuity at that point because we removed it. We actually defined the function value to be the limit, so we can close that gap. And hence, this is removable discontinuity. So out of the two discontinuities, we figured out that the second one is removable. Thank you.